Hello, everybody. This is Monica Paolini from Senza Fili, and today we're going to talk about energy efficiency. Energy efficiency it's a huge topic that it's really hot because it has become so important to make sure not only that your network works well, but also that doesn't consume too much power. And to enable power efficiency, you have to start from the base, from the foundation of your networks. And this is what we're going to talk about today, is how can we make sure that at the network level, the networks are efficient, starting from the very base. And so today I'm talking to Alex Quach, the VP of Wireline and Core Networks Division at Intel, and Cristina Rodriguez, who is the VP of Wireless Access Networks Division at Intel. And it's great to have two people at Intel that are working on different parts of the business. And so we're going to have a vision of the end-to-end game here. When we're trying to be more energy efficient, how do we go about it? And so I'm very excited about this conversation, and I'm sure you're going to learn a lot about this. So let's get started with some introduction, and maybe we can start with Cristina.
Thank you for having us, Monica. Great topic, certainly very close to my heart, and I know I speak for Alex and the entire Intel when I say very close to our heart and our purpose. As you said, I see the RAN. I'm responsible for the RAN business, the radio access network business, or wireless access network business here at Intel, looking at what is happening in the industry from the traditional way to deploy RAN to the virtualized and open way to deploy RAN. How do we make it more efficient, more sustainable? How do we lower the total cost of ownership? How do we bring the best technology into the industry? And how do we work together as an ecosystem to make happen all these ambitions, good plans that we have for the industry and for the world in the future?
So that's a huge amount of ground you cover, and I know that it's not just you started yesterday. You started a long time ago, not just personally, but Intel as a company. Alex, how about you?
Yeah, so as you mentioned, my name is Alex Quach. I manage Intel's business into the core networks of the service providers, and our goal really, and our mission in life, is to deliver the very best solutions, the most performant, most power efficient solutions for service providers to deploy in their core networks.
Perfect. Well, Alex, thank you so much. And thank you, both you, Alex and Cristina, for being with us today. Okay, let's just get started and talk about the high-level strategy at Intel, because clearly you're committed to deliver hardware that is energy efficient, that doesn't consume as much power. But there is much more than that. And this is part of a much higher and broader strategy. So, Cristina, do you want to tell us what is the overarching strategy behind all of this?
Yeah, let's start with the big picture, right? At Intel, our purpose is to create world-changing technology that improves the life of every person on the planet. And it, of course, includes a commitment against the world's critical sustainability challenges. Again, something very close to my heart and our heart. We aspire, as a company, we as a corporation, we aspire to be a global leader in sustainability. And so far, through conversation, through a strong collaboration, through especially application of our technology, we have worked for many years to reduce our environmental impact. And we're advancing more sustainable computing across our entire business. For example, eco-conscious semiconductor manufacturing, more environmentally conscious data centers and networks, circularity across our product life cycles, and just in general, more energy efficient products, platforms, and software. We also, within this, we aspire to enable partners and customers to reduce their own environmental impact through our actions. And examples of this will be, for example, we're working with our PC manufacturer customers to create more sustainable and energy efficient PCs. We are partnering with our cloud service provider customers on data center energy efficiency and carbon reduction metrics. We're engaging with industry and policy makers around the entire world to apply technology that reduces emissions across high impact industry, like networking, for example, which is very close to Alex and me. And we believe that this work with our rich ecosystem across all worldwide industries and applying our technology leadership, together, we can make significant progress on sustainability over the next decade and beyond.
Absolutely. Well, thank you. But now we're going to go the other direction, and we're going to sort of go deeper, because you have clearly a broad strategy, but that broad strategy translates into something that you have to do in a more specific area. So maybe, Alex, you can take us to the other direction now and say,
right, yeah,
what is the run, what is the core?
Sure, Monica. We're going to go from the 100,000 foot level, maybe now down to sort of the practicality implementation. And I think we're going to spend the rest of this time, Cristina and I, talking about how we deliver solutions that really deliver the best power efficiency within the telco networks. Cristina, particularly for the radio access network, myself on the core network side. And as she mentioned, Intel is really an underlying ingredient provider. Service providers don't just deploy CPUs, right? They deploy networks, and networks are made up of software and of hardware. And so we have to work with a broad ecosystem for software application vendors and other vendors in the system to be able to take full advantage of some of the really key features that help with performance and also power efficiency to really bring these features to life. And so in that context, Intel has been working in this telecommunication space, as many of these applications are now moving towards common off-the-shelf server technology running on software to get to the best implementation possible. For that, we need a very broad ecosystem, and we currently have an ecosystem program called the Intel Network Builders, right? There are over 600 ecosystem members, hardware vendors, software vendors, OS vendors, NFV, cloud native, a whole number of solution vendors that are coming together to make this a reality.
Absolutely. There's a lot of things that have to come together, to make it work. So, you start with equipment, all the ecosystem, but then at the core of it, that's a bad pun here, you have to a network that is virtualized, and that starts in Iran. So maybe, Cristina, this is for you. How should we think differently about the network in terms of power efficiency when we have a virtualized network?
Yeah. Great question, Monica, and we're gonna continue going deep into it, right? So we know that 5G networks are transforming the way we communicate, the way we work, the way we play. Right? They enable faster speed, lower latency, higher capacity for data-intensive applications, new services, new business model. All that is great, but this cannot be done at the expense of increased power consumption and against the sustainability goals across industries all over the world. So this is why we see VRAN, virtualized RAN, as a tremendous sustainability opportunity, right? In order to realize all these future that we dream of and that we're building toward, we already knew that we needed the best possible connectivity. Right? We needed the best possible connectivity. We needed the architecture and infrastructure that would allow us to innovate and implement and deploy new functions quickly. And an important part of this is that we need to innovate for sustainability. This architecture that we put together, this equipment that we build has to have sustainability in mind. And that's what is good about an open virtualized network with a full cloud native approach, end-to-end cloud native approach, give us the maximum flexibility, give us the maximum scalability, and precisely the greatest possibility for innovation. And that's why I believe that this virtualization all the way to layer one is an important, it's a critical pillar to our sustainability efforts. From our point of view, from where we stand, our roadmap, our virtualization roadmap is designed for sustainable, scalable mobile networks. We're constantly pushing the boundaries of performance and efficiency. We know that performance per watt is key, and that's what we want to get to, the best solutions with the best outcomes for the operators. An example of this is what we just did. Well, it's not just anymore. It's been a few months that we announced this in Mobile World Congress 2023 in Barcelona, but we have launched already the 4th generation of Xeon scalable processors that can deliver up to twice the capacity without increasing the power consumption, specifically for RAN workloads in comparison to the previous generation. So effectively, this means that our 4th generation of Intel Xeon CPUs will deliver up to twice the performance per watt. And then in addition to that, we have our vRAN boost capability. So we call it 4th generation of Xeon scalable processor with Intel vRAN boost. And now we can, in addition to that double capacity within the same power envelope generation over generation, we can reduce another 20% of compute power consumption. And this is because the way we're architecting the solution, the way we have put together, we have built that CPU has integrated the acceleration, so you don't need any additional component. You don't need any additional card, PCI card in your configuration in your server. And that we believe is game changing for the industry as when it comes to flexibility, TCO, and just sustainability, and just in general outcome for the operators.
Yeah, and I think that this was an important announcement, because clearly, well, it became obvious that you need to have an accelerator. So might as well make it more efficient. And I think we're going to see, as we move forward, more and more changes of this type, because we have to think about it differently. So there are different things that you can do based on what you see in the market and the demand. Now let's look at the core. The core is a little bit more of a difficult topic for energy efficiency, because most of the consumption is in the RAN. So some people say, well, the core, we don't need to do too much there. Well, I'm sure that you don't think that way, but so what do you think?
It's interesting that you say that, because when we interact with service providers, we don't get that reaction at all. Service providers are looking to save every possible watt out there. And when they look at savings in the core networks, they're equally interested in what amount of power they can save, and how this can help with their sustainability goals. So if you look at what's happening in the core, particularly with 5G networks, as service providers move to the next generation core, a standalone core that is more already virtualized, but more into the cloud native environment, they're really concerned that the number of servers are really creeping up to levels where there are going to be more servers needed to support increased traffic. There's going to be more servers to support increased signaling of activities of users on the control plane of the core network. So this is a major concern for service providers. And as Cristina mentioned, Intel is bringing on new technology like the 4th generation Xeon processor where we have in the core network, running a core network workload like the user plane function, a 30% performance improvement generation on generation over the third, the Xeon third generation, and just at exactly the same power levels, right? So exactly same power levels, a 30% performance boost, which represents a 30% increase in performance efficiency. And then on top of that, so just to back up a little bit, right? Service providers, when they look at running servers for the core network workloads, like the #1 criteria for them is performance. That has been absolutely critical for them. It's not something that they're willing to trade off. So now power efficiency and power has become a big deal to save, to save money, to reduce carbon offsets. And really, they're looking to see what is it they can do to, not trade off any performance, any network KPIs, but then reduce power. And in that context, Intel just announced and we made available the Intel Infrastructure Power Manager for 5G Core, which is a piece of software that helps software vendors, and ultimately service providers reduce power consumption in their core networks across the user plane and the control plane by 30% on average of CPU power consumption. So that this is a big deal. If you just take an example of what the impact would be, taking into account, let's say, a 10,000 server deployment at a service provider over 5 years, this represents 400 gigawatt hours of power saved. It represents over $10 million of power savings, and then a reduction of 275,000 megatons of carbon offset.
So let me understand a little bit better here, because so you have some increase in power efficiency, actually decrease in power use at the sort of equipment level. But then on top of that, there is an additional, you provide additional functionality that operators can use depending on their usage model, which is a completely sort of a really something on top. It's not one or the other, but it's the two of them together. And can you give us a sense of how does that work?
Exactly. So the baseline is really simple. We have a new generation of processors. It's improved performance at the same power level, so you get better power efficiency. So that's #1. Let's set that aside. I think the more interesting thing is we have processor states, power states within our processors. They're friendly acronyms called P states and C states. So some of these states, essentially the P states allow for processors to reduce power by reducing the frequencies at which the processors operate on a runtime basis, whereas the C states are more about idle states for the processors. When we look at ways to save power, whether it's in the radio access network with the CU, for example, or whether it's in the 5G core with the user plane function. So these are functions that are basically running traffic, 24/7, right? It never stops. Up until now, everybody is running servers to process these workloads at 100% CPU power, 100% performance, because when the traffic is low, even though the performance is not needed, whenever there's a very high traffic, that power is needed to support the frequencies, to support that amount of traffic coming through. And what we've done is essentially, this is really low-hanging fruit, is essentially provide software that allows the application to follow the traffic models, so that the application, which takes advantage of the CPU will throttle down its frequency and its power consumption when the traffic is low. And when the traffic increases, the CPU frequencies and performance and power consumption will increase with the traffic. So it really matches dynamically on a runtime basis the CPU power consumption along with the traffic flow, as opposed to a static, we're going to consume 100% power all the time, even though the traffic is low. And this is a really great breakthrough. And this is what really allows for power savings, on a runtime basis in the control plane, and again, in certain areas of the radio access network. And we developed this technology working very closely with the service provider, SK Telecom. And they've published a white paper stating a 55% power savings within their network profiles. And now they're asking for this solution from their vendors to implement. We've also been working with vendors like Nokia Networks, who've actually tested the software and seen a 43% power savings on their UPF, as well as vendors like NEC, who've also been testing this software and seeing savings in that range.
No, absolutely. That's very interesting because in the past, what operators would do to make sure they meet their performance, as you say, performance is something they cannot compromise on. But the way to make sure that you have that level of performance, you over provision the network.
Yes.
And that's clearly not power efficient, but now they have a way to do it without, I mean, they can even over provision it, but the over provisioning does not require, I mean, you can over provision it to meet peak, but when you're not at peak, which is most of the time, you don't need to be up to that level.
Yes.
And as you say, that's really going to be a crucial thing, because you cannot reduce more than a certain amount at the equipment level. At some point, you have to work on the software side. So that's excellent. So there is hardware, software on top. Now, Cristina, this is for you. With virtualization, Open RAN, we have more flexibility in the RAN, so we can have it more centralized, more distributed. How is that going to affect power consumption? Because you can make an argument both ways, and maybe there is an argument on both sides. There's no magic solution here.
Well, right off the bat, Monica, virtualization will always give you more flexibility. I say more flexible architecture, and you need that virtualization all the way to layer one. And I say that because it's important. The ability to do power management, to do optimization of multiple algorithms and schedule optimization, and specifically your question, power optimization, you really need that flexibility, that virtualization all the way to the layer one. And the thing is, with that, having an end-to-end cloud native environment give you the possibility to have an architecture that is the same common platform, the same common architecture at the, I want to start with the data center, at the core, at the edge, and at the RAN. And within the RAN, whether you have a virtualized central unit or you have a virtualized distributed unit, you have the same platform and you can do the same kind of techniques. So imagine how much complexity you are eliminating for the operators, and using software capabilities, using software upgrades, applying the latest artificial intelligence technique. For example, you can dial up all those efficiencies, specifically in our topic today, the power efficiency. I wanna talk a little bit more, expand on what Alex was talking about, our unique capabilities for power management, and just looking again at the overall network, the optimization, the power optimization requires, and you said this earlier, Monica, the power optimization requires a holistic approach, right? And I believe there are three elements that need to be there in order to maximize energy savings. One, you need an end-to-end network virtualization all the way to layer one. Two, you need a cloud native environment. And three, you need the advanced silicon power management, the CST and PSTs that Alex was talking about. You need all that present. When you have, for example, we take each of them, when you have an end-to-end network virtualization all the way to layer one, you avoid dedicated hardware, and you can intelligently, through software, optimize the processing resources and power optimization across the entire network. You look then at cloud native environment, you can deploy, the operators can deploy composable applications, and you can deliver new services as new techniques come, artificial intelligence, new algorithm, you can deliver that rapidly. And then finally, to close on this, you have, you go now to the silicon capabilities, and Alex was talking about how can that power be dynamically managed, because in the RAN workload, the demand fluctuates, right? During the day, during the night, that's a no-brainer use case. But yet, even during busy periods, there is fluctuation in the demand. So you can use P states, what we call P states, to module processor frequency and manage your power by doing that. Or you can use C states through which you can put cores to sleep. But the key things here is how fast, how low latency you can bring this core back. We're talking about microseconds here, which is game changing again. And that's, we have examples, just like Alex mentioned a few, but for example, we did a proof of concept with Deutsche Telecom using their own network traffic profiles, where we were able to demonstrate 30%, roughly 30% of energy savings in layer 1 signal processing, again, fine-tuning that core sleep management. We did another proof of concept with Ericsson, and we were able to see 20% savings in quiet period and 10% of savings in busy periods. And our third example was a proof of concept, again, a demo that we did with Vodafone and Wind River, Radisys, Keysight, a group of partners in the ecosystem, where we saw 12% of DU and CU power savings with light traffic. So all this is meaningful, significant power savings by applying virtualization and this holistic approach with virtualization, cloud native, and our advanced silicon power management.
And I think that when you look at through all those trials, all those work you're doing with different operators, what comes up is that the solution, it's an advantage for everybody, but the way the advantage comes in is somewhat different because of the flexibility, the ability to do whatever works for their network, and everybody has a different network and different requirements. And so, when you look at not just one of them, but you look at all of them, kind of holistically, the whole set of them, you do see how important it is, this work that you do on top of having efficient hardware. There is a lot of variability that different operators use in different ways. Now, I have many more questions for you, but unfortunately we need to get to the stop, but I wanted to ask a final question. How do you see this going? So there might be some sort of low-hanging fruits here, but in sort of, if we look at a little bit of the longer run, where do you think that we're going to increase? Where's going to be the source of increase in energy efficiency? Is it going to be the next 6G, AI, better equipment, power consumption, software? What's going to make networks more sustainable? Who wants to go first? Cristina,
I can go first. I would say, number one, this is starting already. This is not a 6G. Of course, it will be get better and better and better, and 6G will be absolutely an important part of it. But this is starting today with 5G, with the network that we have today, with the capabilities that we have today. And I think there is an understanding across the industry that this is something that we have to do, and we have to do now, and the technology exists today to start reaping the benefit of the architecture and the capability of the silicon. Everything is important, right? Everything, every single piece. Again, back to what you and I were saying on the holistic approach. Any levers we can exercise across hardware, software, artificial intelligence, anything of that we need to take advantage of it, and we need to start applying it today. Today, operators, for example, are already looking at AI-driven network optimizations and energy management software solutions to understand and to drive energy efficiencies. And as we look into the future, again, we see a tremendous opportunity, again, harnessing the power of collective innovation in a common platform that everybody understands, where we have thousands of programmers across the world that know how to program there with open source tools and software, collaborating across the industry ecosystem. I think we can come together and have a tremendous impact starting now and continue through the future.
Absolutely. Alex, anything you want to add?
Yeah, that's a really good perspective, Cristina. I think, we talked about low-hanging fruit, which is, these are capabilities that are available in products they're implementing today. So, folks just go ahead and get them implemented, right? That's like real easy stuff to just get off the ground. I mean, it sounds easy, but people just have to go do it. But I think, when you step back and you look at where service providers are at today, what's really critical is the advent of analytics in the world of this transition to cloud native. Because that's a great promise, but service providers today are still trying to figure out where in the networks, like which server clusters, what equipment is consuming what amount of power. I don't think they can even correctly diagnose that today, right? So today we roll up telemetry in support of modulating the CPU frequencies that we've been talking about, right? So very, very low level telemetry is needed, but network analytics to really understand where the power is consumed across the network. I think that's coming about as well as we get smarter and smarter about where the gaps are. And then to be able to shut down whole areas of network or sub areas of network to really reap, yet another dimension of power savings. So I think the network analytics and the intelligence in the network is going to be really critical. The application of AI, of course, would be relevant in this space as well.
Absolutely. Well, thank you so much, and for closing on such a positive note. It's an opportunity. There's a lot of scope and I guess it's like understanding and be able to work more with the technology that we have and that we will continue to develop. So, well, thank you, Alex and Cristina, for sharing your thoughts with us today.
Thank you, Monica.
And this conversation is available also in a transcript, so you can read it as well. And it is part of a report on energy efficiency in wireless on RAN and beyond. And as you see today, we talked about not just the RAN, but the whole end-to-end ecosystem and for wireless. Thank you very much.